This video will take a look at parallelograms, special parallelograms, and kites, but more especially, we will discover something new. Regarding our parallelograms, if you remember, some properties that we learned last year, opposite sides of a parallelogram are always congruent. Even when we drag a vertex of a parallelogram, you can see that the opposite sides are maintained to be congruent. Also, we take a look at the angles. Opposite angles of a parallelogram are congruent. That was what you learned from last year. This year, we will take a look at a diagonal. Here, the orange segment is a diagonal DB. It's a segment that connects two non-consecutive vertices of the parallelogram. Of course, you know that these two sides of a parallelogram are parallel. And if they are parallel, properties of parallel lines tell you that alternate interior angles are congruent. These two sides also are parallel, segment DC and segment AB. And if these are parallel, then the alternate interior angles are congruent. We are not after those because you have studied that. So let's take that out. What I want you to observe is, does the diagonal DB, the orange diagonal, bisect the opposite angles? Are these two angles congruent? Just by looking at it, definitely they are not congruent. So let's take a look at another diagonal, diagonal AC. Note that they intersect at the point H. If I'm going to drag that, take a look at how H plays an important role, the point of intersection of the two diagonals. I'll let you observe segment DH and segment HB. Anything that you observe about segment DH and segment HB? I'll show you the lengths. There. Segment DH and segment HB. No matter how I drag a vertex, you see that segment DH and segment HB are congruent. What does that tell you about point H with regards to the diagonal DB? What does that tell you about point H with the diagonal DB? Let's take a look also at segment CH and segment HA. And the lengths are, if I drag, you can make your own observation about that. So, what can you say about the two diagonals, the two orange diagonals? Where do they intersect? And this is the new conclusion regarding parallelograms. In a parallelogram, the diagonals will intersect, and what do you call this point? Or another way of saying it, in a parallelogram, diagonals each other. Fill up that space and share it with your classmates when you meet.